Hello viewers, welcome to Rexmatics channel. Looking at number base, it is a very important topic for various levels, whether primary, secondary, or even tertiary level. Let's look at the concept of number base. Number base deals with numbers that are less than itself. That is to say, the numbers under base 10 are numbers from 1 to 9, base 9, 1 to 8, base 8, 1 to 7, and so on. Of course, we also have base 11, base 12, up to base 16, which is called hexadecimal. Now, let us look at the universal base, which is base 10. The universal base is base 10, which is also known as denary, or sometimes called decimal. The universal base has applications and operations that are based on the concept of number base. I'll tell you that every day we calculate, we add and subtract, especially. This is what happens. For the addition of numbers, we have 4, 6, 8, for example, plus 9, 5, 9. And then you hear people say 8 plus 9, 17. And you hear something like, write down 7, carry 1. Yes, we are taking 1 to the other side, but it is not because you just have to write down 7 and carry 1. This is the reason. 17 cannot be written under base 10. If not, this would have been the answer. 17 here, 11 here, and 13 here. If we were to be adding in base 20, for example, base 20 can take 13, 11, and 17. But that is not the case. Here we are adding in base 10, which is the universal base, the everyday base. So since it is 17, the concept of number base states that once the number is higher than the base, you take the base away from it and count how many times that base has appeared. So here I'm taking 10 away from 17. And how many times is 10 appearing here? It is once. So I'm hanging that 1 here. And then after taking this away, the remainder is 7. So I drop this here. 6 plus 1 is 7 plus 5. That is 12. 12 is bigger than 10. So it is not just like I said to say, write down 2 and carry 1. That is what you would normally hear. But this is the reason. So when I take 10 away, it gives me remainder 2, and 10 was taken away just once. So I have 4 plus 1 here, 5 plus 9, that's 14. And the same way it happens. The remainder is 4, and 1 is carried over to this side. It is with this concept of the base 10, with this concept of number base, and the application on base 10, that you can successfully, correctly do your additions or subtractions in other bases. Now, let's take the subtraction part of it first. Maybe I have 317 minus 466. Sorry, let's make this 817 minus 466. 7 minus 6 is 1, of course. 1 minus 6 is not possible. When you borrow from this number, when you take something from here, it remains 7. That 1 which you have taken is coming as 10, is representing 10, which is the base. It is representing base 10. So it is 10 you are bringing to this side. When you add 10 to 1, it makes it 11. And because automatically 11 stands like this, that is why you would hear borrow 1 from 8, carry the 1 here. This is the concept of that solution. This is the concept of that operation that as I have brought 1 from this, the one I have brought is standing as 10. So 10 plus this one becomes 11. So 11 minus 6 gives 5, and this gives 3. So that is the concept of number base. Like I said, you can apply this to other bases. For example, 3, 5, 4 plus 2, 4, 3 in base 6. Let's add this in base 6 now. 4 plus 3 is 7. Because 7 is more than 6, I have to take 6 away from it. How many times did I take 6 away from 7? Once. So 7 minus 6, I have to take 6 just once. What is my remainder? My remainder is 1. And because I took 6 away just once, it has to hang here. Why did I take 6 away? Because 4 plus 3 is 7. I cannot have 7 under base 6. I can't even have 6 under base 6. So this is 1 remainder. This is the remainder here and 1 here. 5 plus 1 is 6 plus 4, 10. I cannot write 10 under base 6. I have to take 6 away. How many times did I take 6 away? How many 6s are there in 10? It is just 1. So the 1 is hanging here, and the remainder is 4. 3 plus 1 is 4. 4 plus 2 is 6. Can I write 6 under base 6? No. So how many 6s are there in 6? It is 1. Just 1. So the 1 is coming outside with the remainder 0. So my answer is 1, 0, 4, 1, base 6.